In this lesson, we will examine the technique of assigning variables when solving word problems algebraically. We will begin by completely solving the questions shown here so that we can get an overall picture of what we are trying to accomplish when we solve word problems algebraically. Now ultimately, our goal is to take the given information and translate it into algebraic expressions that show the relationships between the various values. Now in this question, we are given information about the ages of Gail and Eileen, and we want to find Eileen's age. To solve this question, we need to assign variables to certain values and then create an equation to later solve. Now how do we go about assigning variables? Which values do we even choose to assign variables to? Well, there are several guidelines that we can use to help us. One guideline is to consider writing a word equation. Here's what I mean by a word equation. The question tells us that the sum of the two ages is 66. So we can write Eileen's age plus Gail's age equals 66. Now based on this word equation, we can see that in order to write a real equation, we need to represent Eileen's age and Gail's age with algebraic expressions. Now which of these two ages should we assign a variable to? Well, another guideline for assigning variables is that it is often best to assign the variable to the smallest value. So since Eileen is younger than Gail in this question, we might consider assigning a variable to Eileen's age. Another guideline is to consider assigning the variable to the target value. In this question, we are asked to find Eileen's age, so if we let x equal Eileen's age, then when we eventually create an equation and solve it for x, we will then know Eileen's age. Now using the variable x is a common approach, but it's even better to assign descriptive variables so that we have a better idea of what the value of the variable represents. So instead of letting x represent Eileen's age, let's let e represent Eileen's age. Now since we need Eileen's age and Gail's age to create an equation, we still need to find a way to represent Gail's age algebraically. The question tells us that Gail is 10 years older than Eileen. So if we take Eileen's age, which is e, and add 10, this will be Gail's age. At this point, we can write an algebraic equation. We can write Eileen's age, e, plus Gail's age, e plus 10, is equal to 66. All we need to do now is solve the equation for e. First, we can simplify the left-hand side here. Then we will subtract 10 from both sides, and then divide both sides by 2 to get e equals 28. Since e represents Eileen's age, we know that Eileen is 28 years old. Also, since e plus 10 represents Gail's age, we know that Gail is 38 years old. Now please note that this question can also be solved using two variables, which we will examine in a future lesson. For the time being, we are going to solve equations using just one variable. Also note that earlier I said that it is often best to assign the variable to the smallest value. While this is typically true, we can still solve this question by assigning the variable to the larger value. Let's try it. Let's assign the variable g to Gail's age. Now Gail is 10 years older than Eileen, which means that Eileen is 10 years younger than Gail. So if g represents Gail's age, then Eileen's age will be 10 years less, which we can write as g minus 10. Now that we have assigned variables to the two ages, we can take our word equation and now write that Eileen's age, g minus 10, plus Gail's age, g, is equal to 66. From here, we can solve this equation for g by simplifying the left-hand side, then adding 10 to both sides, and then dividing both sides by 2 to get g equals 38. Since g represents Gail's age, we know that Gail is 38 years old. Since g minus 10 represents Eileen's age, we know that Eileen is 28 years old. Okay, so that's the general technique. Now let's practice expressing values as variables. For example, if we are told that there are twice as many cats as dogs, how can we assign variables to the number of cats and the number of dogs? Well, let's follow the guideline that suggests it's better to assign the variable to the smallest value. Since there are fewer dogs here, let's let d represent the number of dogs. Now if D represents the number of dogs, then 2 times D will represent the number of cats. Once again, please note that we are not required to assign the variable to the smallest value. We could also have let C represent the number of cats, and since there are twice as many cats as dogs, the number of dogs will be 1/2 times C. The only real downside here is that we must now deal with fractions, which can sometimes make an equation more cumbersome. Alright, let's try another one. To represent each of these 3 integers, let's let f represent the first number since it must be the smallest. Since we are dealing with consecutive integers here, each number is 1 greater than the number before it. So the second number will be f plus 1, and the third number will equal f plus 2. Alright, what about this one? How do we assign variables to 4 consecutive odd numbers? Well, notice that each consecutive odd number is 2 greater than the number before it. So if we let f represent the first number, then the second number will equal f plus 2, the third number will equal f plus 4, and the fourth number will equal f plus 6. Now in this next example, we are told that the 2010 population was 10% greater than the 2009 population. Since the 2009 population is smaller, let's first let n represent this population. Now if the 2010 population is 10% greater, then we can let 1.1 times n represent the 2010 population. In this next example, we are given information about the relationships between the ages of Larry, Mo, and Curly. Since Mo appears to be the youngest person here, let's let m equal Mo's age. Since Larry is 5 years older than Mo, we can say that m plus 5 represents Larry's age, and now Curly is twice as old as Larry. So if we take Larry's age, which is m plus 5, and then multiply it by 2, this will be equal to Curly's age. Okay, let's try one more. In this question, it is unclear how we might assign variables. Now before we begin assigning variables, we should examine the question and look for any relationships that exist between the values. For this question, we should recognize that each person's contribution is related to the cost of the gift. Maya contributed $7 more than 1/3 the cost of the gift. Clara contributed $10 less than half the cost of the gift. And Tom contributed 20% of the cost of the gift. Since each contribution is given as a relationship to the cost of the gift, let's let G represent the cost of the gift. Now Maya contributed $7 more than 1/3 the cost of the gift. So let's take the cost of the gift and first divide it by 3. This represents 1/3 the cost of the gift. And we are told that Maya contributed $7 more than 1/3 the cost of the gift. So if we add 7 to this, we now have an expression that represents Maya's contribution. Now let's deal with Clara, who contributed $10 less than half the cost of the gift. So first, let's write G over 2 to represent half the cost of the gift, and then we will subtract 10 from this to get Clara's contribution. Finally, if Tom contributed 20% of the cost of the gift, we can say that 20 over 100 times G is equal to Tom's contribution. Okay, that's enough practice assigning variables. Let's summarize. In this lesson, we learned some guidelines for assigning variables. They are: consider assigning the variable to the target value. Consider writing a word equation to help identify the information required to solve the question. It is often best to assign the variable to the smallest value. Try to use descriptive variables instead of using x each time. And look for relationships that exist between the values in the question.